Hello, everyone. Today's webinar would be entitled of EXFO, LTB-8 and 12 automation and remote testing using OptiInstrument 4.0 software. My name is Ahmed Atiyah, and my collaborator from EXFO is Louis Forgate, and my colleague here is Alex Richard. The webinar will include an overview about OptiWave. Then I'm going to talk about the new features of OptiInstrument 4.0 software, which was released recently. Then we're going to do a demo of EXFO LTB-8 remote testbed. My collaborator Louis is going to do the demonstration, and then we're going to do a demonstration of testing, automated testing, and characterization of a 4-channel DMAX module. Then we're going to open for a Q&A session. Okay, OptiWave established in 1994. It's located in Ottawa, Ontario, and mainly we do software products used for designing, simulating, and optimizing different photonics components, links, systems, and networks. OptiWave offers a distinctive software and capability which could shorten the product timeline introduction to the market, as well as it improves the product quality, and it could enhance the productivity and cost effectiveness through the pre-simulation before the product or during the process of manufacturing. OptiWave products, the different products, has been licensed in over than 1,000 industry-leading companies, universities, research, and governmental institutions in over than 80 countries. The main product of OptiWave is categorized into 3 categories. One of them is system level, and it includes the OptiSystem software, OptiSpice software, which is an optoelectronics software. It's mainly designed, can be used for designing photonic integrated circuits. The other packages or category can be it's used for component level simulation. It's like OptiBBM, OptiFiber, OptiFDDT, OptiGrating, and OptiMode. The last category is instrumentation level software, and that is OptiInstrument software, which is mainly today's webinar. We're going to talk about it. Anyone can download any software package from OptiWave's website. You can go to OptiWave website, and then you can go to download, and then click on the 30 days evaluation. A pop-up window is going to appear, and then you will have to register. Once you register, you will be able to download the software, and the location is going to be on the C drive under program files and OptiWave software. As you can see here, this is the location of this software where it is downloaded, and the different packages of the software appearing. Once you click on any of these software packages you downloaded, you're going to see the bin directory documentation, which is a very good resources where you have all the description of the components, the files, examples, and so on. You will be able to also access the executable file, which you can access it from the icon here from the Outlook. This is a picture of OptiInstrument's software installed on a laptop here, as you can see, and communicating with 2 instruments. Right now, it's the function generator and the oscilloscope. The OptiInstrument software applications can be used to communicate with any instrument enabled by SCIBI commands. These instruments can be remotely set or co-located with the host PC or laptop that has OptiInstrument on it, installed on it. The software OptiInstrument can be used to set up the parameters of the equipment, and also can be used to automate and characterize the different devices modules in the setup. We demonstrated in one of the examples added up to OptiInstrument 4.0 example library to test photonic integrated circuit as well. The Software can be used also to write codes or scripts to do long-term stability for testing, let's say, devices, and that can be enabled using the logic commands available in OptiInstrument software. The software can be used to capture waveforms or signals, and can be used to display them in a single wave display, or multiple waves can be displayed on the same screen. You can extract the collected data and save them for post-processing. We enabled post-processing feature in OptiInstrument, and there is a possibility to save the data as JSON files or CSV files or text files. The graphs can be also saved. Displayed graphs can be saved as bitmaps or any format required by the user. The OptiInstrument software can be integrated with other software packages. At OptiWave, we integrate the OptiInstrument with OptiSystem software. So there is a component in OptiSystem software where you can connect remotely with any instrument, get data, and then use this data in the simulations. This is the picture of the OptiInstrument 4.0 GUI. So because we have new icons being added, I'm going to talk about these features added up into OptiInstrument 4.0 in the next slides. The first thing we added up into 4.0 is the GUI. We changed the display waveform setup to allow a new equipment from EXFO, which is called CTB-10 equipment, to be used within OptiInstrument software. So users can be communicating with the CTB-10 and testing modules, passive modules. We're going to show it to you in a second, the display. And then also we allow the users to load files, Python files, to do acquisition of the data, because some equipment manufacturers have their own way of processing the raw data. So we, in OptiInstrument 4.0, we have in the example library a few examples of Python files used for different equipment, from Regal, from Keysight, from EXFO, to be able to process this raw data. Now, as you can see here in this diagram, the new icon, once you click on the display waveform, you get up the pop-up window here, and we had added up this tab here, which is the CTB-10 tab. As you can see, it is having 10 slots in it. So each slot in the equipment, actual equipment, can allow up to 6 detectors. So you can select the slot which has the detector. You can select the specific detector number, and then you choose the functionality you need to test. Is it for insertion losses or polarization dependent loss measurements or return loss measurements? And you can have different functionalities, as you can see here. There is a video about that feature of using CTB-10 on OptiWave's YouTube channel. The other part here, as I mentioned, is the raw data processing. And as you can see here is once you check mark this selection, you'll be able to load a file which has a Python file used for raw data processing. Now, the second part here is the equipment screenshot being added up to the GUI. As you can see, this is the icon. Once you click on it, you would be able to download what is displayed on the equipment. Now, this feature, it only works with the equipment manufacturer, or the equipment with where the manufacturer enables this feature. So as you can see here, this is example from Regal, where we captured what is displayed actually on our software. OptiInstrument is the same thing on the equipment, is exactly matching. Now, the other part also we add up to the GUI is allowing executing of a single command, either in using NI Visa or PyVisa. It used to be NI Visa, which is a C++ pack used in the commands, but right now we allow also the PyVisa. As you can see, this is the single command window, and you can choose between if the commands you wanted to use and build your sequence from it is based on C++ or Python. The other thing is also here we allow the loading of a custom Python files, and this feature is very or actually make it broader applications for OptiInstrument with equipment which is enable, let's say for example Python 0 or something. So in this feature we allow, as you can see here, we have under this command here, you can add up under logic control pane. You can have two icons, as you can see. One of them is to load this custom Python file, and also to delete the files. And this have certain APIs, allows the user to control the equipment and enables the automation. Next is also we add up helpers into the logic control pane here. One of them is the try and accept, and this would help debugging the script. And there is another command we add up as the statement, which is under basic helpers field. And this can be used to, for example, code in the script some pause or adding sound effects or defining variables for state changing the state of the variables from, let's say, string or float or something like that. And these are, as you can see here, there's under the logic tab, and try and accept here, and then the custom Python file, the statement here under that part. Other features we added up into OptiInstrument is the automation of multi-port devices, and this is something which we're going to demonstrate today for measuring passive devices. Like in our case, we're going to measure 4-channel DMAX using the remote setup offered by EXFO. And the process of testing and characterization is enabled, can be done through the command prompt or can be done through the GUI OptiInstrument. Another feature we added up here is loading single JSON file or multiple JSON files. We're going to demonstrate today this feature where you can load these files and display the data in these files, and you can display the collection of the files, and that's what we're going to do. The data measured for the 4-channel DMAX, we're going to first, as you know, you're going to measure reference signal, then you're going to measure the intensity of each channel of the DMAX, and then after that you need to subtract the insertion loss measurement. To calculate the insertion loss measurement, you need to subtract reference from the measured intensity on each channel, and all of that can be done. And these files generated by the JSON file can be displayed. I'm going to show it to you in this demonstration. This is like here, as you can see, this is the reference broadband source used to measure the DMAX, and this is the 4-channel DMAX, which we're going to demonstrate today. The feature where you load the JSON files, this is an icon. You can click on it, and once you click on it, there's a pop-up window here where once you can have two features. Either you have load single JSON file or multiple JSON files. And if you, we're going to show you how to use this feature basically today. The other thing is in OptiInstrument 4.0 release, we added up examples to the example library of the once you download the software, you're going to have you would be able to download the example libraries, which we in the example library created different examples from different vendors or manufacturer of equipment. You're going to see examples from EXFO, from Rigol, from Oztech, from Keysight in the example library. We concentrate today because of our collaboration with EXFO on demonstrating the LTB-8. The example library, as you can see here, description of it, this is EXFO equipment. This is this directory here have examples, old examples from EXFO using the LTB-8, but it's the equipment was sitting in the lab. However, this directory here, it's dedicated for the remote test setup, which is our collaborator Louis is gonna show you how to like how it's been set up, and also we're gonna demonstrate measuring the 4-channel DMAX using this setup here. Okay, now next is here some other examples in the remote test setup examples. Here we created one example which has the script to measure the broadband source, another setup example, to measure a QSFP transceiver, and also to measure BER for that QSFP. And also some other examples we add up for the CTB10 EXFO CTB10 equipment to measure insertion loss and return loss, or insertion loss and BDL. And there is another example added up for from Ostec company, which has temperature controller equipment to control the temperature of a high power laser. So in this script here, in this example, you're gonna see some features added up to include pause to allow the user to do some kind of testing, and also include some kind of warnings using the statement function or command which we added up into OptiInstrument. Okay, now I'm gonna talk about the demo which we're gonna do today. The first part is the EXFO LTB equipment remote test bed, and Louis is gonna talk about it. We have a video actually recorded for these demos, mainly because to avoid any problems with the internet and make sure that we don't have any hiccups. So I'm gonna run this video in a second. The other example here, we're gonna do also a video for the 4-channel automation of testing of the 4-channel DMAX. And finally, I'm gonna show you how to load the JSON files and how to get the display. So I'm gonna start right now the first one with here, as you can see, this is the first video. I'm gonna mute myself.
Thanks,
here.
Ahmad, for this quick introduction. Hello, my name is Louis Forget. I'm a product line manager at EXFO, and I will give you a little bit of feedback about EXFO, product line, and the setup that we're going to use today for the demonstration. At EXFO, we accelerate digital transformation. Basically, we will provide equipment, software, and expertise to our customers to allow them to operate their network at the best efficiency. In order to do so, we provide equipment in 3 different sectors. The first one being manufacturing, design, and research, which is at the start of the chain. Then field installation and field testing, where equipments are used in the field to validate installation. And finally, the network operation, where we help our customers to monitor and make sure that the customer is operating at the best efficiency. EXFO has been around for more than 35 years, and with almost 2,000 employees, we can definitely find an expert to help you out with your solution. You can reach us at any of our global locations. Let's go over the reasons why we want to automate testing. First one would be to increase the speed of each test. If we do more tests per amount of time, we can decrease the cost. So improve the cost. Identifying the location where we have an issue in our processes will definitely help reducing or increasing the yield, so reducing the error amount. Then if we accumulate a large amount of data, which is easier when you do automation, we can do analytics and statistical investigations on our data. And that at the same time, we also participate in the Industry 4.0 movement and get more information out of the tests that we do. EXFO provides a large variety of instruments targeting the lab and manufacturing environment, starting from the small benchtop units and then rack mount devices that can host modules, either optical variety like variable attenuators, optical switches, and power meters, and then transport and datacom units, giving the ability to test transceivers on various layers. Then if we go into larger devices, larger platforms, we can insert optical spectrum analyzers and more up-to-date or faster transceiver testing systems. Speaking about the LTB-8 platform, it can be used as a controller inside an automated test system. As such, it can talk to various equipment like CTP10 or an electrical bird, but it can also talk to external or third-party equipment. In order to orchestrate all of this, we will use an external application. Well, in this case, it's going to be OptiWave OptiInstrument software. Let's see this in action. Okay, so this is what you're looking at right now is the LTB-8 platform that we have at EXFO for remote setup. Basically, this is an LTB-8 that is available on the network for our sales force to explain how to operate an LTB-8 and show the various instruments. So, and on the desktop, you will find the toolbox, which is the main tool that we use to host modules. As I explained earlier, we have the toolbox is able to hold and to operate power meters, optical spectrum analyzers, variable attenuators, OTDR, and the transceiver testing material. So what we call T&D material. So using the LTB-8, I can operate manually each of those devices using their own application. And again, this is only shown on the screen as a demonstration, but at the same time, we also have this setup is actually integrated inside a larger system, which is part of, if I can just show it to you here, this larger system is connected on an MXS 9100 optical switch, which is a matrix switch, which will link all the various devices that you see here using single mode fiber. Let's say, for example, we want to connect there's a transceiver inside the FTBX88200 NGE that is connected to the entry 2, so it's a QSFP. So if we want to connect the output of this transceiver to an OSA, let's say connected directly, we would need to connect port number 2 to port number 7. So if I start the matrix switch demo software, which is the a fully operating application, we get the link between each and every position that you see on the graph at the moment. For now, there's nothing connected simply because this is an early demo. So if we just want to, if we see the connectivity, we have a 24 by 24 switch, and if we want to connect output port of the transceiver to the input port of the OSA module, we need to connect position number 2 to position number 7. So this will effectively link 2 to 7. So now if we go back to Toolbox and we launch Power Blazer and at the same time we launch the OSA. The OSA is currently started and we have nothing on the screen, but that's okay. But if we go to the 88260, which is a BERT tester, if we select Ether BERT, we configure everything. Currently, we have nothing, which is loss of signal simply because there's nothing open, and all the lasers are off. So if we open all the lasers and we look at the OSA on the other end. So if I go back here on the OSA and I do a measurement, which is going to be in the O band, the QSFP that we have is located in the region for LAN WDM. So we have 4 channels, four lasers running at 4 different wavelengths. And this is what we see on the screen. So this is possible only because we connected port number 2 to number 7. And this is true to every position you see on the screen right now. So using this setup, Ahmad is going to show you how to operate the OptiWaves software. And just as a final note, as the LTB-8 is a Windows 10 platform, Windows-based system, it's available directly on the desktop of the application. So we have OptiWave running and OptiInstruments available directly here. I'm not going to go into more details since Ahmad is going to continue with the rest of the demonstration. So please follow on.
Thank you. Okay, let's move back to the presentation.
Now that the table is set for my colleagues at OptiWave to explain how OptiInstrument works, let me just give you a few information regarding EXFO. EXFO.com is available for product information. There's also a series of videos on YouTube on how to talk to instruments using Skippy commands, how to configure instruments. So have a look at them. And the EXFO is never further away than a phone call. Just call our technical support and they will help you find solutions or redirect you in the right direction. So back to you, Ahmed.
Thanks, Louis. Let's go back again to presentation. So now the second part of the demo here, we're going to show how to automate the testing of the 4-channel DMAX and how to characterize it to be able to calculate basically the insertion loss of each channel. And this demo is going to be given by Alex. It's also video recorded because just again to avoid any hiccups in the connection. But the idea here is, as you can see, and Louis mentioned, you have the different cards. As you can see, the cards from the transceiver cards or the DMAX, which is the device we're going to test today. So the DMAX, you're going to have a signal launched into the input, and then each channel you're going to measure the intensity using the optical spectrum analyzer. And so you're gonna connect the broadband source into the input of the DMAX and then measure sequentially the intensity using the OSA of each channel. And then after that, you do the characterization in OptiInstrument software to be able to subtract the reference from the intensity to be able to get the insertion loss. So that part here, I'm gonna run the second demo here. Is given by Alex. So let me run a demo.
Hello. In this example, I'll be demonstrating the 4-channel DMAX module insertion loss measurement on the EXFO LTB-8 remote setup using OptiInstrument 4.0. I will be showing the setup, process, and results. In our first example, to calculate the insertion loss, we will first need to measure the intensity of the reference. Here we will be feeding the 1250 nanometer broadband source to the optical spectrum analyzer. Once we have the intensity of the reference, we will then need to measure the intensity for each channel of the DMAX. In similar fashion, we will be using the broadband source in the optical spectrum analyzer, but this time we will pass the trace through the LAN WDM DMAX for each channel first. As you just saw, the only thing that changed for each measurement was the routing on the optical switch, incrementing from 15 all the way to 18. Therefore, I have two options if I want to do this calculation. One, I could create a for loop that increments the routing after each measurement, or I can run a script using the APIs to change the XML file which calculates each channel separately, which is what I'm going to do in this example. Prior to launching the script, I created 5 XML files, one for the broadband to OSA and the other for broadband to DMAX to OSA. After first connecting to the instrument, it will then load the first XML file. This first XML file will calculate the broadband to OSA. Next, it will load the first DMAX channel, which is at 1295 nanometers. The results will then be saved in a JSON file. It will continue to load, execute, and save the data for each channel, incrementing the nanometer by 5 each time. At the end, we are left with the data for each intensity measurement in a separate file. Now that I have all 5 of my data files saved, what I could do is I can utilize one of the new features, which is the custom Python file loading. What this is you can create your own Python files that do their own calculations and add them to the sequence of commands. In this case, I've created a custom file that does the insertion loss calculation for me. What I need to do now is load this file. This file is actually also provided in the bin directory of the installation. What I can do is I can actually load a file that I've already created. Since you can save the command sequences as XML files, I can actually load it from a previous time that I've made it, just to save us time. Here in this file, you'll see that all I have to do is specify the reference, which is my broadband.json, and the 4 files that I want subtracted. I'll then utilize the functions that were created to do the subtraction for me. If I run this file now, it'll do the calculation, calculate the insertion loss, and then finally save the file in my desired location. What I can do is I can then load this file onto the graph. And here's my insertion loss calculation for the broadband source and the 4 demux channels, with all of its data right here. For any questions, please feel free to contact the OptiWave team. Thank you.
Okay, thanks. So for the next step here, let's continue the presentation. Okay, it's actually this. Okay, so now we did the demonstration for the equipment remotely the remote setup at actually in Quebec City in Canada, and the test was done actually in Ottawa, which is like 400 kilometers away from Quebec City. And as you can see, the beauty of OptiInstrument here is all of this process to control the matrix switch, which Louis has showed us individually for each component. You can do all of that through a script to communicate with the switch, to communicate with the each card, set up the parameter of the cards, and so on. And that's the main advantage of OptiInstrument software, is to allow set up parameters, first communicate, set up parameters, and then measure. And then after that, you can do the characterization, which we saw in the demo done by Alex, is to calculate insertion loss of each channel of the demux. Now, in this part here is the last part, which we gonna show you how to access the JSON file, because once you measure each, let's say each channel, you save it as a JSON file, and then after that you would be able to display and do the characterization. And that part here, I'm gonna go into the other folder here. And actually launch also OptiInstrument. Let me see here if you okay, so I need to minimize this one here. Okay, just give me a second here to launch OptiInstrument. Okay, so I'm gonna launch OptiInstrument GUI right now. And as you can see here in OptiInstrument GUI, to be able to load the different JSON file, you go to this icon here. It's called Load JSON File. So you click on that, and in that part, you can either select a single file or you can select load files from directory. If you do that, you would be able to. You need to be able to save. First step is you need to save all the JSON files in one directory, and then as you can see here, you click on this one, and then you load the files. So if I go to the files from document here, and this is the file, the folder which has all the JSON files. I'm going to show you these files actually in a second. And then what you see here, it say okay, and then okay, and then now the OptiInstrument would start to read the different JSON files and then load them and display the results of them. Now note here, please, that the number of JSON files, as you can see here, this is the JSON files which I loaded: 1, 2, 3, 4, 5, 6 files, 4 channel intensity, and then the reference, and then the calculation of insertion loss, to demonstrate that part. And as you can see here, basically all the data for the JSON file has been read and tabulated in a spreadsheet. And then also here, as you can see, the graph for every data file. So you can see the intensity of this part here, the reference, the intensity of each channel, and then the insertion loss calculation by subtracting the intensity from the reference. Okay, so that part here, let me continue. So go back again into the presentation. So now the thing is, in OptiInstrument here at OptiWave, we try to propagate this message to the viewers and to the users in the market, that OptiWave OptiInstrument software can communicate with any equipment. Like, I mean, it's not dedicated to a vendor, although we demonstrate today with EXFO. However, as I mentioned, you can talk to any equipment in the market as long as it supports Skippy commands or Python serial commands. So we should be able to actually communicate with the equipment, set it, and then do the measurements and characterization. The other part is also at OptiWave, we are open to help any user to integrate their own equipment and provide scripts to automate their setups. So if you have any request to integrate any equipment, you can communicate with OptiWave team you can communicate with my email here, as you see, or at support@OptiWave, and then we can work on integrating your equipment with our software and help you in creating scripts for that. With this, I conclude the presentation, and we are open now for Q&A. And I'm going to invite our collaborator Louis here, and also Alex to join this part. So, see the first question here: is it possible to characterize high-speed transceiver using the LTB-8? So maybe Louis, if you could answer this question, please.
Yes, thanks, Ahmad. Yes, definitely we can test various models of transceivers and using the transceiver FTB-X88 series from EXFO. You have the ability to adapt and to connect to various types and various models of transceivers from 1 gig, 10 gigs, 100 gig, and all the way to 400 gig transceivers. You will have the ability to test all the characteristics, typical characteristics of a transceiver, which is the receiver sensitivity side, the transceiver portion where you want to measure the wavelength, the output power, and that kind of measurement, and of course the measure the bit error rate attached to it. Okay. So yeah, we definitely have the ability to test high-speed transceivers.
Okay, so is there like this question is actually from me, is what is the maximum speed you can support on these transceivers? Do you?
Well, at the moment, the speed of the transceivers, the module that are supporting high-speed transceivers will go all the way to 400 gig. Okay. We just announced, I think it was yesterday, a new model for testing transceivers, QSFP. And again, I'm not the transceiver specialist. It would be more for my colleagues to answer that question. But basically, we have the ability to run or to measure and characterize transceivers all the way up to 400 gig.
Okay, thanks. I'm sorry I put you on the spot, but it's a good question actually, because transceivers is a hot market right now, right? So it's important to address that. Thanks.
Totally.
Okay, so other question is here. Do you have scripts for characterizing transceivers? I'm not sure. Maybe Alex, if you could answer the question here.
Yeah, we have an example library with examples from the Power Blazer, from the OTTR, and yeah, so like we have different like a full example library with every single module that was seen in the video from the EXFO equipment.
Okay. Okay, so the example library, usually the users, once they download the software, they will have access to this example library, which have examples and scripts for controlling different instruments from different vendors, basically, right? So, okay, thanks, Alex. Another question here: what are the other EXFO equipment that OptiInstrument supports? Maybe Louis, if you could answer this question, please.
Yeah, well, actually, as soon as you have the ability to talk to an instrument using Skippy commands, it becomes available in the library. Skippy commands is basically sending text using a standardized protocol. This is an industry-wide protocol. National Instruments has been integrating that inside their libraries, and OptiWave tap on that facility and that capability to interact with basically any instrument that talks Skippy. So, and of course, we have a lot of instruments in our portfolio that do connect using Skippy commands. All the optical and laboratory type of devices, including, of course, the LTB-8, LTB-12 platforms, and all the modules that fit inside, will have the ability to interact with the OptiWave on OptiInstrument.
Okay, thanks, Louis. Another question here we have: how to build script from scratch? Maybe Alex, if you could elaborate on this, please.
Yeah, so the way to build a script from scratch is first of all to connect to your instrument, connect any other instruments you have using either TCP/IP, serial, USB, and then once you're connected, what you do is you would drag in Skippy commands or type your own, and then there's an icon up top where you can add it to the overall sequence, and from there, like you can, like as you're adding commands, you can run them. You can also use kind of like what we added in the library, like helper functions, so for loops, if statements, and then like in combination with these Skippy commands, you can have like all types of like logic. You can assign variables. Also, like what we saw in the presentation is you can actually like add your own Python script from there. So you can create your own classes. Let's say your class, you wanted to add 2 variables. You can actually create like the Python file for that. You can load it in, and then you can drag in your own function. So you can actually, it can be kind of as sophisticated as you want it to be. And it's just like a drag and drop. So it's very simple. You just drag and drop. You run the program, you see what the results are, and from there you would modify based on how you want it. So it's very modular. It's very flexible, and in that sense, it makes it more powerful just because it's up to you, kind of like what you want to add to it, and all the capabilities are there.
Thanks.
And just to add a pile a little bit on what Alex just said, we're using Python as a scripting language, or of course you have the script that is easy drag and drop, but the ability to transfer that into Python gives you a huge increment in the ability to write other types of sequence and address other link to other libraries as well. So it's extremely flexible and powerful in that regard.
And just also to add up on this comment, actually, thanks, Louis, is in OptiInstrument, we didn't show it, but it's something which was already in older versions of OptiInstrument versions, like I think is 1 or 2. We had this feature of having a Python script where you can convert actually the sequence of commands into Python, and you can run it from the Python editor or from or PowerShell or command prompt. So you have lots of flexibility in working with OptiInstrument in Python environment, basically. Okay, so another question here is, do you offer scripting service to automate our equipment? So, like, I mean, so for example, if someone wants to buy an equipment or he has an equipment, do OptiWave offer scripting service or support? I think I can answer this question definitely. I mean, we are open, as I mentioned in the message, that we are open to work with any customer to automate their own equipment and create scripts for them and help them in building the equipment. So that's the whole purpose of this OptiInstrument software offering. I'm not sure if Louis, you have anything on it to add, or?
Yeah, it's the same here. If as I explained in the last portion of my slide, we have a couple of training videos that talk to or explain how the Skippy commands are established, but we also have support from our support team that can help, especially on the how to connect and how to operate the devices. Of course, if you want to write new code, we're not going to explain you how to write down code, but at the same time, if you get stuck with one command that you want to execute and you don't know how to do it, we can of course help you find the right information in the user guide.
Perfect, thanks. And also, like, if you look at any equipment, basically it comes with the manual which has the Skippy commands in it, and then you can. That's actually, you can look at these commands, test it in OptiInstrument single command window, and make sure that it works. And then based on that, you build your sequence of commands. So it's a step-by-step process. Okay, thanks. Another question is about do OptiInstrument support the automation of multiple equipment from different vendors? So I think as we talked about this is like OptiInstrument is not dedicated to a specific vendor. We can work with any equipment and any vendor who has supports KB commands or serial Python, for example, commands which added up through the custom Python files, as we showed you today. So yeah, OptiInstrument is a versatile software which can talk to any equipment. Okay, another question here is about the cost of OptiInstrument software. I'm not sure, maybe Sawyer, if you can comment on this.
Yeah, it's a good question. So we offer very competitive price for our customers. But it depends on how many users you need for one license. Moreover, we also provide very heavily discounted price for our academic customers. So if you are interested, please send your contact information to support at OptiWave. We'll be happy to provide you the official quote.
Okay, perfect, thanks. So yeah, you have the emails here as you see, support and my email address, and then there is info@optiwave.com. If you have any question, if you need support, you need to inquiry about the cost and all of these things, please don't hesitate to communicate with us. So
one more thing, Luis answered a question to someone regarding the remote setup to get demo on LTB-8. Maybe Luis, you talk about this.
Yeah, thanks, Sawyer, to point that out. I answered by typing, but basically the remote setup that we use today is dedicated for the EXFO sales force. But of course, any customer can build their own test environment using the LTB-8, access this device using Windows, how's it called? Windows desktop, remote desktop, and communicate with a station that is located at a distance. As Ahmad and Alex pointed out, they access this setup using privileged access, but they do it from Ottawa while I'm located in Quebec City. So they have no issue to interact with the remote distant devices. If you want to talk or if you want to have a demo or specific setup, you can talk to our sales force, and we will definitely be able to arrange a demonstration session. That will be our pleasure. And if you want to have a more limited setup, but it is available all the time, we have http //demosample.exfo.com, which is a sample that shows optical devices, optical modules, and interaction. So we have the ability to show this, and it's open 24/7 all the time. So it just simply gives you the ability to learn how to operate manually the UI, the user interface of those applications. So if you have any questions, please contact me or any Salesforce representatives.
Okay, perfect. Thanks, Louis. Thanks, Alex and Sawyer. So I think there's no more question here, and then we can conclude this webinar. Thank you for attending, everyone here, and have a good day. Bye-bye.
Thank you, guys.